Okay, the next topic is tubular reabsorption and secretions. Proximal convoluted tubule, where you're going to have reabsorption, as you can see in there, and secretion. So let's take a look at this figure right here. And this is a proximal convoluted tubule. So what's going to happen in here? We're going to secrete and we're going to reabsorb. So as you can see here, for example, we are absorbing water, this passive transportation. We secrete. Take a look at this arrow, for example. You see the hydrogen going this way and the sodium going this other way? These are pumps. So then what type of mechanisms we have in the proximal convoluted tubule? Active mechanisms, such as pumps, or passive mechanisms, such as osmosis and diffusion. So in this proximal convoluted tubule, there is reabsorption and secretion. Reabsorption and secretion of what? Basically salt, glucose, nitrogenous waste, and water. Right there, you have sodium chloride. Other electrolytes, such as, for example, hydrogen, glucose. We filter glucose, but we reabsorb it. Why? Because we need glucose in order to form ATP. Nitrogenous waste, remember we said the nitrogenous wastes are urea, uric acid, creatinine, and ammonia. Very important to remember is that we don't eliminate the whole entire nitrogenous waste. We eliminate enough in order to have a normal life. Next one is water. We said that is by osmosis. It follows, for example, sodium. Uptake by peritubular capillaries, that's by osmosis. That's what you do with water, right? Osmosis helps you reabsorb the water back into the circulatory system. Then we scroll down. Transport maximum, there's only a certain number of pumps that can allow us to transport glucose. Tubular secretion, like we filter urea, uric acid, but we also secrete these nitrogenous waste into the tubes in order to eliminate that. Nephron loops, secretion and reabsorption, but this has a very important purpose. If you can see here, is to generate osmotic gradients that enable the collecting duct to concentrate the urine. Basically, the nephron loop is going to secrete and reabsorb, yes, but with the purposes of making the job of the collecting duct easy. Distal convoluted tubule, again, it secretes and reabsorbs, but in this case, this is controlled by hormones. Hormones such as what? Such as aldosterone. Aldosterone reabsorbs sodium from the tubes, and water follows the sodium, and that's how you reabsorb sodium and water into your blood. Natriuretic peptides, such as, for example, the one that you produce in your heart, called atrial natriuretic peptide, that one inhibits the absorption of salt. If you inhibit the absorption of salt, water doesn't follow, therefore you don't increase the pressure in your blood. Antidiuretic hormone, that one is going to help you keep water in your body. You don't urinate a lot. Cases in which you need water in your body, like when you are dehydrated. Parathyroid hormone, this is related to calcium. The parathyroid hormone is going to work to increase the reabsorption of calcium from the tubes back into your blood when it's necessary. And if we keep scrolling down, that's about it. So the next topic is water conservation, and this happens at the level of the collecting duct. Right there, the collecting duct, which is this one. The collecting duct is going to help you make your urine diluted or concentrated. How do you achieve that? Because the collecting duct is going to eliminate water, or it's going to keep the water in there in order to dilute your urine. How the collecting duct is going to achieve that? That's because of the loop of Henle. The loop of Henle is the main partner of the collecting duct for that purpose. So what happens in here is you have in the descending leg, you see sodium comes out, and you see here the concentration. So let's say, just to make things easier, this is 300 pounds, 400 pounds, 600 pounds, 900 pounds. How come this is becoming concentrated? Because water is coming out. 1200 pounds. But what happens right here? Look, 700 pounds, 400 pounds, 200 pounds. Why? Because more sodium chloride is coming out. There's a lot of sodium chloride right here because of these pumps that you see right there. This is the medulla. So what happens? Counter current multiplier. So this is not concentrated at all, right? Because it's just 100 and you have a lot of water in here. So whatever is going to turn into urine reaches the collecting duct. Let's say you are dehydrated. So what do you need? You need a lot of water in your body. So since you have in here water, what's going to happen is this goes down, and then this collecting duct is going to allow the water to come out. How come the water comes out? Because you're going to have this high concentration of sodium chloride, which is salt, and the salt is going to attract the water that is in here. Since the salt attracts the water that is in here, all the water starts coming out. Water comes out, water comes out, water comes out, and your urine becomes very concentrated. So you have a lot of water in the renal medulla. Where do you need this water? You need it in your blood. For that, you have in here the vasa recta. That excess of water that you have in your renal medulla gets reabsorbed into your bloodstream, therefore increasing the amount of water, and therefore you were dehydrated, but now you're becoming hydrated because you are not eliminating all that water by urine. That's why your urine is very concentrated, but that excess amount of water now is going to go back into your bloodstream. How do you call this process by which the water goes back from this area where there is a lot of water back into the bloodstream? This is countercurrent exchange. So let's keep scrolling down. And that's what you have in there, the counter-current exchange that happens in the vasa recta. We keep scrolling down. You see in there all the hormones that affect the reabsorption and secretion of substances in your kidneys. So this is the reabsorption and secretion that is necessary in your body in order to maintain homeostasis. Collecting duct allows the water to come out because in the collecting duct, you have the antidiuretic hormone. The antidiuretic hormone works in the collecting duct, promoting the formation of some channels in here. It's a lot of channels, and these channels are specific for water. So you have in here an excess of sodium chloride that is going to reabsorb the water, but also the collecting duct is going to help by providing all these channels that will allow the water to come out. And that's what's going to happen in the cases of dehydration. So what happens when you are not dehydrated? Then you don't have the channels, so you don't reabsorb the water, so your urine is not very concentrated, right? It's just normal. Okay, so that's about it for this part.